Now here are the rest of the Chapter 11 notes. This is conic sections, and we're going to touch on some other nonlinear systems of equations. It makes a little more sense after you know what the conic sections look like. So we have 4 different types of conic sections, and they are called conic sections because they result in the intersection of a plane with a pair of cones. Sometimes the plane intersects only one cone, like here in the parabola if we intersect at a slant, and here in the circle when we intersect perpendicular to the cone. We have an ellipse. Once we tip that perpendicular plane just slightly, and then when we intersect the plane with both of the cones, we get 2 pieces. This is what we call a hyperbola. Probably familiar with parabola and circle. And I will be honest, the only reason we are talking about page 1 is for these pictures up front. We are not actually going to use the equation, conic section version of the equation for the parabola, because you have a nice understanding of parabola. We've graphed those using standard form, using vertex form, using factored form. This form, while useful, just kind of mucks everything up. So this is the one conic section we are going to bypass. If you have an interest in this, the notes are down the left-hand side, and we can talk about that later. We are going to go on to page 2. We have the standard form of the equation for a circle. Okay, so the standard equation of a circle with a center HK, which means we took our 0, 0 and moved it H horizontally and K vertically, just like we do with other equations. We get this equation, x minus h quantity squared plus y minus k quantity squared equals r squared. Now, if we go backwards looking at the equation, if we can make it look like that, an x minus something quantity squared, a y minus something quantity squared equals another number, we know the center, we know the radius, that makes it really easy to graph. Okay. So we are going to start with something we haven't used a whole lot, and that is completing the square. I am going to start by reorganizing this. So my x terms are together, and I'm going to leave a little space, and my y terms are together. Again, I'm going to leave a little space, and then I'm going to move my constant to the other side. Okay. Now we have a process for completing the square. We cut that linear term in half as far as my x's are concerned. Half of negative 16 is negative 8, and then I square that and add it on. So half of b is negative 8, add on. We are going to do the same thing with the y's. Half of 14 is 7. When I square 7, I get 49. Now we're going to factor. This gives me an x minus 8 times x minus 8. I get a y plus 7 times y plus 7. I get 32 plus, so negative 32 plus 64 is 32. 32 plus 49 is 81. I got x minus 8 quantity squared, y plus 7, quantity squared equals 81. And just so it matches the formula, I'm going to write it as 9 squared. Okay. Now keep in mind this has to be in terms of x minus and y minus. So I have a vertex of 8, negative 7. I have got a radius of 9. So let's talk about how we graph this. My vertex, positive 8, negative 7. Right here. Nope, that's negative 9. Right here. And if my radius is 9, I'm going to use this the easiest way possible. I'm going to go straight up. 1, 2, 3, 4, 5, 6, 7, 8, 9. Straight down. 1, 2, 3, 4, 5, 6, 7, 8. There's 9. I'm going to go 9 to the right. 2, 3, 4, 5, 6, 7, 8, 9. And 9 to the left. 1, 2, 3, 4, 5, 6, 7, 8, 9. These 4 points are on my circle, so then it's just a circle around, super circly looking, except then I have Notability that does that for me. Okay, and it came in a little tight, but there's our circle. Try that one more time. So not a circle. Definitely not a circle. Question is, how many times are you going to sit and watch me try to draw a circle? Jeez. Anyway, first one was a little off, but at least it was the best. There we go. Still a little off, but we'll take it. Okay, so as long as you have the vertex and the radius, super easy to draw the circle.